we are trying to finish up this review before our test on Thursday. So the quicker we get through this, kind of the better. And move some stuff around here. All my little notes to myself. Okay. I'll probably hit it on myself somewhere, I'm sure of it. That's just the way it works for me. Need to go get some other markers that are a little bit easier to see on the board. Sharpie does not belong in there. Can't remember what it is. Okay. So yesterday we left off with 11, and now on to 12 and 13. Who can tell me what we need to do for 12 and for 13? What does it ask you to do?
Determine the truth value.
Is that everything that we need to do?
I need to use the little example.
So I need to use the example, and you say truth value. We were only on number 9?
No, whoa. We did all.
Were we just on number 9?
We finished.
This is where we're at?
We finished 11,
Yeah.
12.
Cause they were all like the little truths, so you went on them real quick. It was like,
So you might need to watch the video or get with someone to get, make sure you got 9, 10, 11. That's right. Yeah, 9, 10, 11. From what I remember, we were at finished 11 yesterday,
yeah.
and we were just about to start this 12 and 13. And Ash is like, I really don't think so. I remember finishing those, and I think other people have them written down. Perhaps, like, you got 9. I don't see 10, 9, 10, 11, yeah. So I doubt that they probably went and did like 9, 10, 11 on their own. I'm not sure what's happened there, okay? Tell you what, let's go back really quickly at 9, 10, 11, just so that everyone's on board. We needed to identify hypothesis and conclusion of the condition. And we found that this was the hypothesis and this was the conclusion because we were seeing this if and then. Okay? For 10, you kind of had the same deal, if, then. That meant that this first part is the hypothesis, the second part's the conclusion. 11, we didn't have that. We don't have an if, then to help us. So we have to, in our brain, rework this so that we do have an if, then. That we have hypothesis, if an angle measures less than 90, conclusion, the angle is an acute angle. Right? That's pretty much what we have to do is break that up and be able to put that into an if-then statement. Okay, so that's where we finished up yesterday. Do I need to leave this up for a minute? Make sure people get it down. Now the next thing here, okay, tell me what we need to do. I heard from people, give the truth value. That was not enough. If that's what you do on the test, if all you do is tell me the truth value, that is not enough. What do the instructions ask you to do?
If it's true, explain your reasoning, and if it's false, give a counter example.
So there's really 2 parts. I have to explain whether it's true or false. Give that truth value. Is it true? Is it false? And depending upon that answer, I have to explain why it's true or give a counterexample to prove it false. Okay, this is what I'm kind of complaining about. I've been on your case for a couple days or longer. Okay, you can't just look at that, pull out that piece of information, and that's all you give me. Read the instruction to make sure that you have included all parts. Because you know what you're doing. But you literally are like putting like your arm in a sling and one behind your back to try to do the math. You know, when you're doing your grades, I can only give you credit for what you did. Allow me to give you full credit. But that requires doing all the parts that you were asked for. Please. Okay? I think this is shaping up to be a really good test. I think you guys got this. But you have to give me everything that I need to give you credit for. If you only give me half, that's all you're going to see for your grade. No one wants a 50 or a 60 for a test grade, especially when you know what you're doing. Okay? So here, step 1, I need the truth value for the conditional. And then number 2, I either have to explain the reasoning or give the counterexample. Okay, so I have to provide 2 pieces. The truth value and what's the evidence for that truth value. Okay, so for number 12, okay, we have this conditional. If angle 1, that's this one right here, and angle 2, that's this one right here, if they form a linear pair, do we remember what a linear pair is? Kind of. That's not the best explanation, but it kind of explains it. Anyone else want to give it a try as to what a linear pair is? This is something that you need to dredge out of your memory. It doesn't go away. What do you think, Melanie?
They're on the same line.
They're on the same line? Sort of. Like that's the way our brains work, and I understand that. The definition of the linear pair is about 2 different rays that are going in opposite directions so that they do form a straight line. Do you understand the difference? Like they are forming a line. They are, we do have things all along one line, but it's because of the fact that our 2 different rays that are the exterior of angle 1 and angle 2, not the one that is connecting them, are going in opposite directions, and therefore they make a straight line. It's an important distinction, okay, for a linear pair. So if we have this being the case for angle 1 and angle 2, can we say that they are supplementary angles? Is that true or is that false?
That's true.
It's true. Why?
Because you have the rays going to the opposite side, so it has to be supplementary.
Yes. Okay. So if the rays are going in opposite directions, that are the exterior sides of angle 1 and angle 2, that means that they're forming a 180-degree angle because it's a straight line, and that is exactly what supplementary means. Supplementary means that the 2 add together to make 180 degrees. So I need to say that it's true and give that reasoning. If you give me one part of that, you get 50% of that. I can't give you full credit. So you're going to say, this is true, and explain that a linear pair has exterior rays
directions forming a 180-degree angle and supplementary means they add to 180 degrees.
So that matches, it matches up. Do I sometimes have to write an explanation more than 2 words? Yeah. But it's not stuff you don't know, you just gotta be patient and write it out. That's the stuff you know, but you're afraid to take the space on the paper and you're afraid to use your words. Half the battle about doing stuff for assessments, for tests, is just literally explaining what you know. You don't have to always do it in the shortest way possible. You don't have to spend pages, but give enough words that you're understood. Not like, oh, well, maybe, I'm not really sure, but give enough that I know, yes, this is the way it is. Okay? Can I erase that? Move forward? Okay. Just checking, making sure. Let's look at this next one. It says if angle 1 and angle 4, so we're dealing with this angle now and this angle. If those two form a linear pair, they are congruent angles. Quincy's like, no. He's like, that's false. Why? What we need to do now, if false, give a counterexample. So give me an example where they aren't congruent. You're on the right track. And there's many different examples you could use. I just need one. What's an example where they aren't congruent? Congruent means same what? Same measure, same size, right? So all we need is an example where they are a linear pair, but they're not the same size. So give me an example. Give me the counter example.
Oh, so like angle 1 is just angle 1 is 60, and then angle like 4 is 120.
Would you agree? Like that's a possible.
Can't you just say that one's acute, one's obtuse?
You could say that, but one thing that we're gonna need is that we need to make sure that whatever example we give, we have to explain how they add up to 180. Okay, but we could have acute and obtuse adding to 180. Okay. Is it possible that we could have acute and obtuse that are more than 180? We could. You know, what happens if I have 80 and 160? Like this is obtuse, this is acute, but it would be far more than 180. So I think for a counterexample, you're maybe a little bit better off providing some numbers. Otherwise, if you just say acute and obtuse, I would make an extra thing saying that the two angles have to add up to 180 beyond that. Okay, so here, false, provide the counterexample, and that proves it to be false. Okay, because 60 and 120 are not the same size, quite obviously. Okay, let's go up to 14. Okay. It says, use the Venn diagrams below to determine the truth value of each conditional and explain your reasoning. So what do I need to do? How many things do I need to provide? in my answer?
You need to determine the true value and explain the reason.
So I need the truth value, need the reasoning. Make sure you have both. Okay? And we can use these as our proof for whether these are true or false. 14. If a polygon is a square, then it is a rectangle. True or false?
That's false.
Oh, you said what?
Why do you say false?
They said what? What did you say?
If a polygon is a square, then it is a rectangle.
Because a square could just be a square.
But isn't a square a rectangle?
Yeah.
In this case, all squares are part of the rectangle.
Well, yeah, but what if you have a square that's
How do you define what a rectangle is? Rectangle has four sides,
with
4 right
two-
angles, right?
Yeah. And then
So
with
would
two
you
different
agree that
lengths.
this is a rectangle?
Yeah.
Is this a rectangle?
Yeah.
How about this?
Yeah, that's a square.
They're all
That's a
rectangles.
rectangle.
4 right angles, 4 sides.
Then what's a square?
In the case of the square, all 4 sides have to be the same size.
All squares are
Rectangles, you don't have to have the same size for all 4 sides. You're gonna have the same width, same length. Does that make sense?
All,
So this is a rectangle, this is a rectangle, this is a rectangle, this is a rectangle. What makes this a square is that all of the side lengths have to be the same.
Did you say a square is a rectangle?
Yes.
all squares are.
Oh.
rectangles.
All squares are rectangles, not all rectangles are squares.
Okay,
But
well,
all
that was
squares,
just a lack
all
of
their
knowledge.
sides are equal, but a rectangle isn't. So why isn't a square just a square by itself?
Because a square
That's
is
So
a
four.
because
square
a square
and a
has 4 sides and 4 right angles. So this is 4 sides, 4 right angles. Okay? That's for this. This is the same thing, 4 sides, 4 right angles, and all sides same length. This one requires an additional thing on top of that to make it part of that elite group. It's like, you know, all of you are students at WCS, right? You know, are all students part of the football team?
No.
No. Does that suddenly make you not a student at WCS if you're part of the football team? So if you look at it that way, if we look at, so this is WCS students, this is just members of the football team, it's a subset, it's a smaller group. Does that make sense?
No.
So squares are rectangles, they're just a smaller group where there was another qualification that was needed in order for them to be squares. Does the analogy help?
Yeah.
Okay. I understand. This is one of these things that logically we're trying to wrestle with because we like to think that they're different somehow. But no, all we're doing is we're adding an extra thing. Oh, well, they're not just WCS, but they're part of the football team. Okay, they're WCS, they're football team, but they're also NHS members. Okay, they are, and we could add further and further smaller groups as we add qualifications. That's all that's happening right here. Okay? So, if a polygon is a square, so if it is one of these things here, is it a rectangle?
Yeah.
Why? says that
Because all
this is
squares
true,
are rectangles.
okay? That if I have a member of this square group, all members of the square group, are also rectangles. All members of the football team are WCS students. If they weren't, that would be a problem. Don't think TAPS would be too happy with this. Okay, how about 15? We have to look at this one. It says if two lines are perpendicular, then they cannot be parallel.
That's true.
Also true? Why?
Because looking at the Venn diagram, the two circles don't overlap each other, so
Okay.
there's no way that you can be both.
Now, I'm gonna write a shortcut here, okay? I'm gonna tell you that perpendicular, I can also write like this. This means perpendicular. Parallel, we can write like that. Okay, it's kind of a symbol that means parallel and perpendicular. Okay, so true because the groups for perpendicular and parallel do not overlap. They don't even touch each other. They're two completely separate things. Are we doing better with these Venn diagrams, hopefully? Like if I have a perpendicular line, it has to be part of this group. That can never be part of that, according to this diagram. Are we ready for 60? Get it.
Baltimore Ravens.
How about if a polygon is a rectangle? If we switch this around, and I said that if a polygon is a rectangle, then it is a square. Can we prove that to be a true conditional or a false? Why do you say false?
All rectangles are squares.
Not all rectangles are squares. That would be a little bit better. I think you're right in your reasoning. Sometimes it's just the right order of words. Not all rectangles are squares. Okay, it is possible that we could have something that's a rectangle, but it doesn't meet that square condition. Meaning that we have something that has 4 right angles, it does have 4 sides, but the sides are not the same length. And so this easily becomes false when we just switch that around. Okay, let's look at 60. Okay. A lot more words.
Was this actually true or is memory?
I would assume that this is something that they pulled from history. It seems kind of random that they would just make this up. Okay, so the Baltimore Ravens played the San Francisco 49ers in the 2013 Super Bowl.
Yeah, this is true.
Okay.
Quick.
Determine whether whether the stated conclusion is valid based on the given information. If not, write invalid and explain your reasoning. Okay, so what do we need to do?
Determine
Determine
whether
if
the
it's
study
not-
conclusion is valid, and then based on the given information,
So what's the first step?
determine whether.
Determine is this valid
No.
or invalid? Okay, second, if it's not valid,
Then
explain why. Okay? So I need to determine is this valid? And secondly, if it's not, explain. Okay, the Super Bowl winner, this is the given. We know this one to be true, but we don't know if that's true. The Super Bowl winner has the highest score at the end of the game. I think we know this from every sport. Is there any sports where you have, no, actually golf.
Golf.
Golf. Lower score wins. At the end of the game, Ravens had a score of 34. 49ers had a score of 31. Conclusion, the Ravens won the Super Bowl. Is that true or false?
True.
Okay, it is true. Can you explain your reasoning?
Highest score wins.
Highest score wins.
Highest score wins.
Ravens scored more than 49ers.
And it's a factual statement.
Yeah. Like this one is common sense, I realize. But it still follows that same format. Okay, so this we conclude is true. Ravens scored more than 49ers. Done. We good? We're feeling a little bit more confident? Maybe? We're finishing this up pretty quick today. That's a good thing. Okay.
Let's look at 17.
Please be valid.
Please do what?
Said please be valid.
Can we fit this on the screen? Okay. What do we need to do here, guys?
Determine which statement follows logically from the given statement.
So how many answers are there?
6.
How many answers am I supposed to give?
1.
One. So this is a case where all you have to do is pick the right answer. Okay? Unlike the other things where we had to do multiple parts, this is your typical multiple choice. Pick the best answer. Okay? So we have to look at these two statements, which are true. Now, do you remember what lesson 2.4 was about?
No, deductive.
It was deductive,
Deductive, that's what I said.
but what about the deductive? There were a couple things that we learned. There was a law of and a law of.
Law of attachment.
Law of detachment
And syllogism.
and the law of syllogism. Now, what did the law of detachment essentially tell me in the terms of P and Q?
If P is true, if P
So
to
if I
Q
have P going to Q,
is a true statement,
and if P is true, then
He was true.
Q is true. How about syllogism?
if P to Q and
So we have P going to Q, and then Q going to R.
And then P to R is a true
So then we would have P just going going to R. That one thing leads to another. Sound familiar? Hopefully. So what do I have happening here? If you are a junior in high school, then you are at least 16 years old. Okay, they're saying that this is true. Whether or not it is in real life, doesn't really matter. We have P going to Q. If you are at least 16 years old, then you're old enough to drive. So this is what? You say this is P to Q? Nathan, you seem a little unsure.
No, this is like. No, this is P to R.
This is what?
This is P to Q and then Q to R.
Okay, Nathan says that this is not P and Q, that this is really Q and R.
Because it's restating
Oh.
Q and then it's
Yeah.
giving you another statement.
Then you are at least 16 years old. If you're at least 16 years old, so we have P to Q, Q to R. Okay? So what am I expecting to find then? And my answer choice is, what am I expecting to find?
P to R.
I want to find P leading to R. Do I have that?
C.
Yeah, C.
If you are a junior in high school, then you're old enough to drive.
Because I'm about to turn 16 on the papers.
And honestly,
Pretty
there's
other
plenty of people that
Yeah,
are
I'm
older
sure a
and they
bunch
don't
of-
drive.
Yeah, a bunch
But-
of other people are 16.
According to these statements, okay, the logical conclusion is, if you're a junior in high school, then you're old enough to drive.
Actually.
So don't forget that law of detachment and that law of syllogism. I think they're fairly easy to remember. Maybe not their names, but remembering that I have two laws, and that one just goes P to Q, and if P is true, Q is true, and the other one, P to Q, Q to R, so P to R. Like that's the shorthand in my brain as I'm thinking about those. Okay, remember that also on your test that you are going to be able to use those postulates and theorems. So 2.5, that's when we are dealing with postulates, theorems, and definitions. We need to provide the facts, the proofs. Okay? So here, what do I need to provide for my answer? Richard. What do I need to provide in my answer for 18, 19, and 20? How many pieces of info? Sort of. What's the first thing that you would do, Elijah, for like number 18? Given the instructions, what's the first thing you gotta do?
Always, sometimes, and never.
Yeah, explain. Well, just give, is this always, sometimes, or never true? That's step 1. Okay? Quincy, what's step 2? After we give always, sometimes, or never, explain. Explain why. And that's where you are invoking this as, hey, here's why. And write it out. Okay? So points J, K, L, and N. I have 4 points. They are non-collinear and lie in the same plane. Is that always, sometimes, or never true? Why do you say always? What backs that? what theorem or postulate?
2.4.
Okay,
Blake
so
between
you
the-
said always, and you're saying 2.4. Okay, 2.4 says,
A plane contains 3 possible points.
What is 2.4 saying?
he says a plane contains at least 3 non-collinear points.
Okay, wait. But okay, so non-collinear means that they're not on the same line, right?
Yeah.
So,
That makes
I don't know if I'm right or wrong, but okay. So if you have like line JK
Okay,
and line LN in the same plane, then technically you still have 3 non-collinear points. Because J, L, and N are not on the same line. I'm sorry, K, L, and like you know what I'm saying? So it's like
could you draw it for us? Would that be possible? Yeah,
okay, wait,
sometimes you drawing it can help us.
no, I just need to figure out how to draw it.
I understand.
Okay.
So right now, we're trying to figure out, is this the case?
Wait,
I'm not sure that it is.
sometimes.
Why do you say that?
So are non-collinear, which means that they're not on a line.
Yes, they're not on the same
So
line.
planes J, K, L, and N are non-collinear.
So this is, again, remember that we have a statement where we have a hypothesis and a conclusion. From this, can we conclude that they lie in the same plane? Sometimes, never, always.
So they're saying that if points J, K, L, and N are non-collinear, then they can lie. Then they lie in the same place. They don't have to lie in the same place if they're not collinear.
Okay.
If they're not. If
So
they're-
you're saying that would you agree that this says that they can be?
Yes.
Okay. Are you disagreeing with this part?
Yes.
So Jeremiah says he thinks it's sometimes. Can you provide a counterexample to show why it's only sometimes?
I mean, you can have 3 middle planes and 1 dot.
Okay.
Or they could be.
So he's saying like you could have 3 here that are all in the plane. You could have J, K, L, like that. And I think Nathan was trying to get to this earlier. What happens if I have this other point up here? That is, again, not collinear. That's on this line that intersects.
Or you can have it on. Or they could. 2 can be on 1 plane.
Yeah. But is this a counterexample? It is. This is a counterexample as to why this is only sometimes true. It could be that all 4 are in the same plane somehow and on different lines.
It says they all lie in the same.
No. We're trying to, it says determine whether this is always true, sometimes true, or never true. So if we have 4 non-collinear points, meaning that I have 4 points that aren't in the same line, is this always true? We're trying to prove this. Is this always true if they're non-collinear? Is this sometimes true if they're non-collinear? Or is this never true when they're non-collinear?
like if the points are non-collinear, then they don't have a boundary.
It says they're non-collinear and lie in the same
No.
plane.
This is not necessarily true. This is the hypothesis. This is what we're given. And we're trying to see if this conclusion is always, sometimes, or never true. We don't know for sure if this is true or not. That's why, like, if this were all, if this were true and this were true, we wouldn't even have this type of question. If that were always the case. So what we have is, they tell us this is our given, in a way, but this part is, we're trying to prove, is that the logical follow-up from this piece of information. Okay, which is why I was separating it into your hypothesis, J, K, L, N, non-collinear. Can I conclude from knowing that all 4 points are non-collinear that they all lie in the same plane? We know that 3 non-collinear points will actually define a plane, but that 4th one is the thing that it could be in a different plane. I don't know if there's another way that someone can think to explain this. Might just have to come back to it. Because I can't think of another way yet. The best is really this right here.
Yeah.
We have no way of knowing that this is always like this. These 4 points could be all in the same plane, or it could be that 3 of them are in the same plane, but 1 of them is outside of that plane. In either case, we have 4 non-collinear points. But here, they're non-collinear, but all are at the same level. Here, 3 are all at that same level, like a piece of paper, but that 4th one is somewhere else in space.
Like the way I think of it is
So
like,
all of them aren't in the plane?
No,
like the way I think
not
about
always.
it is that like a plane is like a boundary.
Like this is, sometimes it could be this, sometimes it could be this. We are trying to see, is this part, is that always, sometimes, or never? It's the same thing for this. There's exactly 1 law, 2 points R and S. We're trying to prove, is that always, sometimes, or never? Sometimes it's true, so, in this case, but it's not always true. It is, literally, your answer for this is sometimes, and it is because of postulate 2.4, that because of postulate 2.4, this is sometimes the case. Because I have 3 or more points, can be that, it has at least 3, but here, I have 3 points, it defines a plane, but that 4th one could be somewhere else.
I don't agree with you.
Yeah. I would appreciate any help we can get in understanding this, because I know that we need different viewpoints. I mean, if you want a different color, would that help?
So realistically, like, so me, Trina, Fernando, and Quincy are all at the school right now. So we all are in 1 plane right now.
Okay, I like your analogy.
Well, what happens after we leave school? Some people leave the plane. So it could be me, Quincy, and Trina, but Fernando left. He's at another plane, like his house.
So those 4 points, those 4 people still exist. Sometimes they're all going to be in that same location, that same level. Sometimes one of them won't be.
Yeah, and sometimes they would never be, because I mean, none of us could say the
Yeah,
school
it could be 4 different locations. I agree. So sometimes it's true that you're all going to be that one location, that one plane, but it's not always. And it's not never. You know, you, as students here, you would all have to be here at some point. Okay? I think that was a really good analogy. Okay? Let's look at 19. Again, we're trying to find, is this always, sometimes, or never true? That there's exactly one line through points R and S. This one I think you're going to find a lot easier. Look at your postulates.
Oh, it's 2.1.
Okay, this is true because 2.1, and we need to say postulate. I can't just say 2.1. Unless in the question they say, explain your reasoning using a postulate.
Is it always true? Always true.
This one is always true. You're right. I put true instead of always. This should be always true. Why? Postulate 2.1, which says?
Any 2 points there is exactly right.
Okay, through any 2 points, there is exactly one line. Not more than one, only one. Because any other way of joining these points other than a line wouldn't be a line, it would be some other weird connection. So there's always exactly one line through 2 points. Okay, how about line A contains only point Q?
Well, not would be never.
That would be never? Why?
Because the one has to have at least 2 points.
Okay, find the postulate that backs that one.
3.
Okay, you said 2.3, 2.3 says that a line contains,
At least 2 points.
yeah, that would work. A line contains at least 2 points, would definitely disprove that. Okay, a line is containing many points. You coming by after school?